right? We have these now three different major number systems that are decimal, binary, octal, hexadecimal. So we are comfortable with the decimal number system because we have 10 fingers and it is easy to write, easy to count, and easy to work with. And in a Python, as simple as you have, if you write 89, which is a decimal number. But how can you write a octal number in Python? Octal numbers are prefixed with the O. Okay, so 0 O, okay, 76. Okay, that is how you can represent a number, octal number in Python. Okay, which is 62. Can you see? Octal equivalent, decimal equivalent of 76. Octal 76 is 62. Okay, so I can actually take x equal to, okay, 42 or 32. Okay, so we have different functions in Python to convert these given decimal number into different number systems. One is OCT, octal. I can pass decimal number to get the octal equivalent. And we have x, and we can pass the decimal number to get the hexadecimal number. And we have bin, and we can pass that binary number x and to get the binary equivalent of that number 32. Okay, and as you can see, by looking at the output itself, you can actually recognize, oh, this is a way to represent numbers in that number system, in that format. Okay, so this is a different format representing the same value, different format, which is octal number system format, right? This is hexadecimal number system, number represented in hexadecimal format. Okay, so you see this one 0x20, which gives us 32. That is how we represent 32. So how do you represent 255? 255, which is actually decimal number, but in hexadecimal, which is just ff, which is 255. And so you can actually get the octal equivalent of hexadecimal number. You see 0377, which is octal. And in fact, you can combine 0x, which is 20 plus 32. What you will get? Yes, 64. Python works with this different number systems, seamlessly. You can represent numbers in different number system formats. Okay, so, and we have 0b0110, which means a 6. Okay, so in Python, like this, we can represent a number in a octal format, hexadecimal format, and binary format. Okay, so now let's come here. So we have these different number systems. We have seen how to represent them in Python. And what is a truth table? This is AND. What is truth table for AND? If the both conditions are true. Which means if I have 1 here, it should, if it's 0, 0, right? 0, 1, 1, 0, okay, 1, 1. So how it works? If the both are true, then only it will be true, which means here also false, and in only one condition it is true, which is AND, bitwise AND. So same thing you can perform on Python. Okay, take this x equal to, take a equal to 0b00110, b equal to, let me take a 0b1010. If I perform A and B, what you will get? If I do A and B, what you will get? Okay, so that I can actually convert this thing a bin of A and B. What you will get? So you can actually prefix any number of zeros. This is equivalent to 0010. Okay, so how it works here? Yeah, yeah, because 10, which is 0 1 0 for 1 1 we got 1, but for 0 0 we got 0. So that is how A and B gave us 2. Understood? Okay. So, and how this works, if bitwise and or we have 0 0 0 1. Oh, that is bitwise or operator. How it works here? True, it's true, right? So only the condition it is false, both conditions are false. And how it works? In which cases we can use that actually, logical or operator, which works the same way, logical or operator. Y- yeah, truth table same, but they are applied on both different. They are applied on different expressions to actually combine them logically. But here, it is applied on bits. Okay, so same here, applying A we have, B we have. If I do A and B, what you will get? Yeah, sorry, A or B. If I do that, you see that because the first one here, 0 0 0 1 0 1 0, sorry, 0 1 1 1 0 1 1 1 1. See, that is the reason we have 3 ones. And then last one is 0 because both are zeros. So A are giving us, B giving us 14, while A is 6, B is 10. Thing is that, here the always result we should expect and we would get in a decimal only. Understood? Okay. So you can actually be 0110 or 0B1010. What you will get? 14. Okay. So now what is another one, which is bitwise? Bitwise or XOR, exclusive OR. Okay, XOR stands for exclusive OR. So what is XOR? That is quite interesting. That is truth table of XOR. So the interesting thing is you will get true when both, either one of them is true, not in neither cases. If both are false, if both are true, we will get false. That is the reason exclusive, it is called exclusive OR. Okay, so it performs OR exclusively. Okay, so exclusive OR, that is the reason it is called. So when you can actually use this one, you can use this when you wanted to check either one of them is true, but not both of them is false, not both of them is true. Okay, so which, how it works, it is actually a b, this, the formula for this one is a bar b plus b a bar, sorry, a bar b plus b bar a. Okay, that is a formula. So anyway, which means that, you know, first we perform the a b, which means we a bar b, which means that complement the a and b and perform AND operation. Okay, okay, on both plus means AND operation. Okay, so that is how this exclusive OR is computed, and the result what we get here, you know, which is exclusively, bit is set if either of them is true. Okay, so check this one, how it works. We have x, y, sorry, a, b, we have a cap b, which is exclusive OR. Okay, so the same thing, check this thing, bin of a cap b, what you will get here, right? Can you see? You can see here, see, first one is true because one of them is for the first bit, leftmost bit, true because one of them is true. Okay, one of them is 1, and the leftmost second bit is also true because one of them is true, but rightmost 2 bits are false. That is the reason we got this 1100. Okay, that is 12. Okay, so, and we have the complement. What is complement? Still, okay, if I give 1, it performs one's complement, which means that negate whatever you have. Okay, so if I have a 0b 110, okay, if I complement that, what you will get? -7. Okay, so you can actually get bin of -7. You can see, what do you see here? Okay, so minus, because these there are actually number systems, we have negative numbers are represented using one's complement or two's complement. Okay, so, and no, see, we when you negate everything, you know, that one's complement, so leftmost bit represents the negative symbol sign. Okay, yeah, show me, let me show you. So you see this one, binary number representation, and when you represent negative numbers, signed numbers, we use okay, signed magnitude, one's complement and two's complement. So where the leftmost bit, if it is 1, that represents a sign. You see, this is a sign bit. Okay, so since we are performing complement, the all leftmost bits are converted to ones, so that is the reason we are getting negative. Understood? Okay, yeah, so that is complement. And what we have here, and we have left shift and right shift. Okay, the left shift, right shift. How this left shift, right shift works? You have A, okay, and let's say we have B, okay, bin of which is 0. So bin of A, which is 0B, 0B0110, right? So if I right shift, okay, 2 bits, okay, number of bits you wanted to shift, okay. So which means that bits are shifted to right and filling those bits zeros, and any if they actually, this bit is shifted, this one is shifted to right once and again twice, that bit will be discarded, okay, passing that rightmost bit. So how it works here, shifting one, let me first show you how shift one actually is. It makes sense if I actually convert that to binary. Can you see? So these two ones are shifted right ones, okay, making up to the place where we have 0. Understood? And if I do this twice, we are left with single one only, because rightmost one is discarded as we shifted once. Understood? Okay, that is how bits are actually shifted. So that is the right shift. How left shift works, basically, left shift works, okay, so bits are not discarded. Can you see here, this 110, they shifted left, so we got 1100. Got it? So if I shift them twice, we got here, see, twice adding we got 3 zeros, right? That is how bitwise operators work. And so these are helpful when performing, when dealing with, low level stuff, dealing with some bits and pieces, or especially these are also helpful when we deal with the network traffic, network information, okay, and when we wanted to work with flags, network information, or low level stuff such as uh, drivers. Of course, we may not code drivers in Python, but we could use bindings. So these are helpful when dealing with network information, flags, and drivers. Okay, and so creatively we can use them sometimes to actually choose decisions. So we can use exclusive OR. Since we don't have a logical exclusive OR operator, we can use exclusive OR. uh, Drop in replacement, we don't have of course, for replacement we don't have logical exclusive OR. We can use exclusive OR to actually compute a scenario where we wanted to do that particular scenario when either of one is true but not both of them is false, and not when both of them is true. Okay, in such a case we use these operators, XOR.